So today's topic is about acids and bases, and let's start thinking about where that fits into stuff we already know. Well, we already know some things about solutions. Solutions are things that have a solute, they have a solvent, solutes are mixed into the solvent, and that creates different kinds of homogeneous mixtures. Well, today we're going to focus on two specific kinds of homogeneous mixtures called acids and bases. To put this into context, places you might have heard about this is, if you've ever swam in a pool, you may know that the pools must be tested so that there's something called pH that's correct, so it's not too high or low when you're swimming in the pool. That way it keeps it safe based on not being able to spread diseases, but not too many chemicals that could be harmful to your skin, that kind of stuff. This also could be true if you've ever had a fish tank. You maybe had to test it, something called its pH, that would make sure that the chemicals in there are the right balance so that the fish can survive in there. This is true in ponds, in rivers, in hot tubs. All of that is trying to keep things at the right balance, and that's all related to acids and bases. So that's going to be our focus for today. So to start in on this, let's talk a little bit about what the chemistry definition of acids and bases are. The definition of an acid is a solution that has hydrogen ions. And remember, ions are just something with this charge, so we're going to call that those are H pluses. So hydrogen ions as the solute. And this definition is a specific definition named after this guy named Svante Arrhenius is his name. Here's a picture of him, so you get a visual here. So we use this as our example because his definition applies to just about any type of acids and bases that you're going to come up with. So let's go ahead and give him some credit here. So Svante Arrhenius. Those are two R's, so Arrhenius. Svante Arrhenius. So according to his definition, H pluses, if those are floating around as your solute, then that makes it an acid. So if you start with something neutral like water and you pour in something that produces H pluses, that would now be considered an acid. And the properties, so properties, remember, are describing words. Properties are going to be things like they taste sour. So if you imagine tasting something and it gives you that like face puckering face, that means that it's probably acidic. Also, it will produce gas with metals. So if you put metal into an acid sample, it will start to bubble. It will produce gas. It will also do that if you put a sample of some type of carbonate. Think of something like sodium bicarbonate, which happens to be baking soda. Baking soda, if you pour it into vinegar, vinegar happens to be a type of acid, you get that bubbling, that foaming. Well, that's what makes it, that's one of the things that defines it as an acid. So if you take an acid and you mix it with metals, or you mix it with carbonates, you will produce gases, bubbles. Another property is that it will conduct electricity, which is kind of interesting because there's ions floating around. It's kind of like having a battery in that solution and it will conduct electricity. So some common examples, so let's get a visual here. Here's some common acid examples. Go ahead and pick 3 of them from this list. Things like lemon juice or citrus fruit. Maybe you've heard of citric acid. That sour taste is because of that acid that's in there. There's acid in your stomach. This is what helps dissolve your food. It happens to be hydrochloric acid. This is why, this is kind of gross, but right before you throw up, sometimes you get that sour taste in your mouth. Well, that's because there's that acid from your stomach that's now in your mouth. This is also why it's really dangerous for anyone that has an eating disorder where they throw up a lot, because that acid can start to wear away their esophagus lining, the enamel on their teeth, and that can be a really bad thing. Soda, a lot of sodas have acids in them. It gives them that tangy or sour or citrusy taste. Milk actually has just a little bit of acid in it, and the older it gets, if you think about it, we call that sour milk. Well, it's sour milk because it's starting to produce more and more lactic acid in there. Lactose can break down into lactic acid, and that makes it sour. Vinegar is a common acid. This is why pickles taste sour. Pickles are cucumbers soaked in vinegar and salt and water, and so that sour taste comes from the vinegar. And a lot of times just our spit can be acidic because there's possibly some of the chemicals from our stomach that are getting into our spit and to our saliva, and so that can also be an option. So 3 common examples, write down at least 3 of them. Here's a bunch of things that you probably have heard of. All right, so you write down 3 of those. You put those in your common examples. All right. Let's continue on with our definitions and let's talk about bases. Now we're still going to use our Svante Arrhenius definition, only for bases, this is a solution that has hydroxide ions Remember, hydroxide from our peach seed is OH with a minus charge. So because it has a negative charge for that particle, that calls it an ion. So this is this idea, you're creating a solution. So maybe you start with something neutral like water. Whatever you pour into that water is something that is producing OH minuses because that's what the solute is. So the properties for bases are going to be things like they taste bitter. So if you think about things that you might have gotten in your mouth that taste bitter, bitter is like that dry feeling on your tongue. And also they feel slippery. And one of the cool things about this, the reason they feel slippery is they're actually dissolving the cell casing on your skin cells, and then the stuff inside the cell oozes out. So that base dissolves that casing of your cell. It doesn't hurt very much because the outer layer of your skin is dead, but if you had a base that could get deep enough into the deeper layers of your tissue, it would be very, very painful because it's dissolving those skin cells. Common examples of bases, take a look at these, are a lot of times things that are cleaners, so like shampoos and Windex or other types of cleaners. Tums would be another example. If you think about what Tums are used for, well, Tums is a medicine. Usually you think about it for heartburn. Well, heartburn is not really your heart burning. What it is it's acid from your stomach that is splashing up into your esophagus. And the Tums, which are considered a base, are trying to balance out that acid that's not where it's supposed to be. So that's an example of bases. So shampoos, cleaners, different kinds of cleaners, and then Tums. Shampoos, just as a side note, sometimes you can have acidic shampoos. If your hair is really frizzy, you might get an acid shampoo because that actually will help your hair follicles lie straight. So some connections between things in your real life and acids and bases and this chemistry stuff. All right, so write down those common examples. Okay. Well, the next thing I want to talk about that's related to acids and bases is this thing called pH. And it's called this, the reason it's a small p and a capital H is because the capital H actually refers to hydrogens. So what you're doing is you're measuring the H plus concentration. If you think of concentration, again, that's just the amount of stuff in a certain amount of solution. So specifically, it's the amount of H plus. And what it's telling us then, since if you remember back up here, H plus is our definition for acid. So really pH is telling us how acidic something is, or really not acidic, which of course could also mean base. But by definition, pH is either telling us yes, it's an acid or no, it's not an acid. Now, the only thing that's kind of weird is that pH is based on an opposite math function. So if you have a low pH, that actually means that the solution is an acid. So even though you would think, oh, if it's telling us the pH, more H's should be acid, the pH scale is based on a math function that's an opposite log math function. So it's the opposite. Low H's, a low pH means there's actually a lot of H pluses, so that's going to be an acid. So that means that if it is a high pH, that means there's actually not a lot of H pluses, so that's going to be your base. And then if we say that the H's are kind of balanced out, they're really not more or less than anything else, then we say that the solution is neutral, and that will be your pH of around 7. So high numbers are base because it's an opposite function, meaning there's not a lot of H pluses. Low pHs are acid because it's an opposite function. It means there's a lot of H pluses. And then if it's somewhere around 7, then that's neutral. That's the pH scale. So one other way to kind of think about these pH scales or acids and bases is to think about that the amount of H's, which is acid, the amount of OH's, which is base, if you can compare those two, you can kind of decide whether or not it's an acid or a base. So remember that H pluses are what define acids, and OH minuses are what define bases. So if the concentration, because these brackets here really mean molarity, so let me just make a note of that. So these brackets really mean molarity. Remember, molarity is the amount of moles per liter. So really this is saying the moles of H's divided by the liters of solution. If that is higher than the OH's, well, H's define acids, that means the solution will be acidic. So this is another way. So if there's more OH's, that makes it acidic. If the H's and the OH's are pretty much balanced, well, think about this. H plus and OH minus come together, well, that's really H2O. And H2O is really just what? Yeah, water. So that makes it neutral. When the acids and the bases, if the H's and the OH's are pretty much balanced, then that's going to be neutral. If the OH minuses are a higher concentration than the H's, well, OH minuses are defined as bases, so the OH would be higher, then that means you have a base solution. Okay? So those are some ways that we measure acids and bases, some ways we define acids and bases, and try to give you some context of things in your world. One other place that you might have context in your world about acids is thinking about acid rain. Well, the way it works is that there's some pollutants that get into the air. That air mixes with water vapor. That water vapor and those pollutants fall as acid rain, and then that can be damaging to like marble structures, which are made of carbonates. It can be damaging to trees or plants or animals. If the acid rain falls too much too fast, then nature can't really balance itself out. But it turns out that most of the time nature kind of fixes itself, and kind of the animals and plants just kind of adapt to that high acid level. All right, so the last thing I want you to do before we move on is I want you to do a little bit of pH quick research, like it says. So what I want you to do is I want you to think of 5 solutions you use in a normal day. Things that you use when you're getting ready in the bathroom, things you use in the kitchen, or things in your garage, or things for cleaning. 5 solutions, and write those in here. Then just tell me what they're used for, used for cleaning, used for drinking, using for washing hair, whatever it is. And then I want you to do an internet search and look up their pH. And you can literally just type in something like pH of blank, whatever your thing is, pH of shampoo, or whatever it is. Then, based on your pH, decide is it acid, base, or neutral. Remember, acid is low pH, base is right around 7, and neutral is higher than 7. That's how you'll decide. When you're done with that, go ahead and show me, and then we'll move on to our next thing. Thanks for listening.